Hello everyone, welcome back to my channel Master Computer Science subject. Today in this video we are going to see the second example for the construction of LR parser. So this is a grammar I have taken. S derives L equal to R, S derives R, L derives star R, L derives ID, R derives L. For this grammar, the very first step what we are going to do is the construction of LR0 automaton. So how do we do that? So first we need to augment the grammar. So what is the augmented grammar? Take a new start symbol, let it be S dash. That should derive the start symbol of this given grammar. So S dash derives S and keep the dot at the leftmost. Right? So after dot, if a variable appears, for that variable whatever the rules are there, those rules are to be included. So what is a variable appearing here? It is appearing S. So let us include the rules for S here. S derives dot L equal to R. Another rule is S derives dot R. We have included the rules for S. Now again analyze the position of the dot. After dot there is a variable L, there is a variable R. So we have to include the rules for L as well as for R. Let us do that. L derives dot star R, L derives dot ID, R derives dot L. So by the way, we have included all the required rules. After dot there is a star here, after dot there is ID, which are all terminals. After dot there is L here. Already we have included the rules for L also. So this is the start state of this LR0 automaton. Let us call this initial state as I0. From this I0 we are going to define transitions, and on those transitions we are going to find the resulting states also. So on what symbols we have to define the transitions from I0? After dot, whatever the symbol appears, on all those symbols we have to find the transition. So we have to define transition on S, we have to define transition on L, we have to define transition on star, transition on star R, as well as we have to define transition on ID. So let us define the transitions from I0 on reading S. It means you have to find the rules based on the position of the dot, which is going to read the S as the next symbol. So this is the only rule we have. So modify that. S dash derives. Now it read S, so the dot position is kept after S. So after dot there are no symbol. Further there are no rules to be included in this state. That's all. The state is over. Let us call this state as I1. Now from I0 on reading L. So on reading L, which rules it can choose to read L? This rule as well as this rule, both the rules have L after the dot. So let us include both the rules. S derives L dot equal to R. This is one rule. After dot there is equal to, so there is nothing much more to include. Now let us consider this rule also. R derives dot L. So that's all. R derives L dot. After reading L, the dot position is shifted next to L. So these are the two rules we have to include in this state. Let us call the state as I2. Now from the state I0 on reading R. So what is a modification happens to I0? So which is a rule we have to choose? This is a rule we have to choose because this has R after the dot. So if I modify S derives, it will become R dot. After dot, since there is no symbol, there are further no rules to be added in this state. So this is one state. Let us call this state as I3. Now from I0 on reading star, what will happen? L derives after reading star, the dot is shifted after star, then there is R. So after dot there is a variable R, so we have to include the rules for R. So what is the rule we have? R derives dot L. When you are including the rules, make sure that the dot is at the leftmost end, right? R derives dot L. So after dot it is demanding the rules for L, isn't it? Because it is a variable, so we have to include the rules for L also. Let us include that. L derives dot star R, L derives dot ID. So that's all. I think further no more rules to be included here, because after dot we have seen the terminals. Let us call the state as I3. Now from the state I0 on reading ID, the rule modified is L derives ID dot. Let us call this state as I5. So from I0 we have defined the transition on S, L, R, star and ID. Now let us continue defining the transitions from the other states. From I1 there is no transition to be defined because the dot is at the rightmost end. From I2 we can define transition on equal to. So if we define transition on equal to, what happens? S derives L equal to dot R. So the dot is kept after equal to. It means LR parser has read the equal to. Now it is yet to explore the variable R. If it is going to explore the variable R, obviously we have to include the rules for R, isn't it? So R derives dot L. We have included this rule, right? So now it is demanding further to include the rules for L also. So include the rule L derives dot star R, L derives dot ID. Further no more rules to be included. Let us call the state as I6. From I2 we can define transition only on equal to, that we have defined. Now from I3 there are no transitions to be defined. From I4, this is I4 in fact, from I4 let us define transition on R. So the rule is modified like this: L derives star R dot. After reading R it is modified like this. Further no more rules to be included because after dot there is no symbol appearing here. So let us close this state and we call the state as I7. Now from I4 on reading L, the rule modified is this rule: R derives L dot. Further no rules to be included. Let us call the state as I8. From I4 on reading star, if the parser reads the star, the dot is shifted after right to the star. So the rule becomes like L derives star dot R, the first rule. Then afterwards we need to include the rules of R, then we need to include the rules of L. Actually I4 on star, on the transition, on the symbol star, it enters into the same state I4. Similarly from I4 on a reading ID, it is entering into the state I5. Okay. Now let us continue transition from I6. From I6 on a reading R, the rule modified is S derives L equal to R dot. That's all. Further no more rules to be included. So from I6 on reading R, the state is I9. From I6 on reading L, R derives dot L will be modified as R derives L dot. It means it is entering into the state I8. So similarly from I6 on reading star, it enters into the state I4 because it will result in the state I4. From I6 on reading ID, it will enter into the state I5. I think further there are no transitions. Let us go through the states once again. This is I0. From I0 we define transition on S, L, R, star, ID. Correspondingly on S it went to I1. From I1 further we can't make any transition. From I0 on reading L, it entered into the state I2. On R it entered into the state I3. From I3 no transitions further. From star it entered into the state I4. From ID it entered into the state I5, isn't it? From I2 we can make a transition on equal to because that is the only symbol possible. On equal to, if we make a transition, it entered into the state I6. Then from I4 on R it entered into the state I7. On L I8. On star, in fact it is a self loop. I4 on star enters into I4 itself. It is a self loop in fact. I4 on ID, it enters into the state I5. From I6, there are 4 transitions, L equal to ID and R. Correspondingly, the states are written. So the very first step is over. We constructed the LR0 automaton. Now what is the second step? The second step is the construction of SLR parsing table. I have already shown the parsing table here. Even you can see this. This SLR parsing table contains 2 major columns. One is action, another one is go to. The rows are nothing but the states. Since the LR0 automaton already contains starting from 0 to 9th state, I have numbered here. And action column contains the sub columns for all the terminals equal to star ID dollar, and the go to column contains the columns for the variables, which is S, L and R. Anyhow, to perform this step, apart from LR0 automaton, we need to compute the first and follow also. So let us compute the first and follow set here. So what is first of S? First of S is first of L as well as first of R. First of S is first of L as well as first of R. So what is first of L? It is star as well as ID. Star as well as ID. So first of S is also star ID. First of R also says that it is first of L. In fact, first of R is also star ID. Now we have to compute the follow set for all the symbols, isn't it? So what is follow of S? By default, we have to include the dollar symbol. And we don't have any production rule which contains S on the right hand side. So follow set of S contains only the dollar symbol. What is follow of L? Follow of L is equal to. So that I have included. Any other symbol which contains L rule here? Yes. This rule contains L on the right hand side. So follow of L, actually there are no symbols. Follow of L is nothing but follow of R. But till now we have not identified what is follow of R. So first let us identify what is follow of R. What is follow of R? From these two rules we know that follow of R is follow of S. And follow of R is follow of L also. So dollar is to be included here and equal to is to be included here, because follow set of L and R is one and the same. Now we are moving on to the second step, which is nothing but filling the SLR parsing table just by looking into the LR0 automaton. From I0 on reading S, it goes to the state 1. So let me write 1 here. From I0 on reading L, it enters into the state 2. From I0 on reading R, it enters into the state 3. So I have entered as 3. From I0 on reading the terminal star, it enters into the state I4. But while you are entering here in the action column, we have to enter it as S4. So let me enter the value here as S4. From I0 on reading ID, it enters into the state I5, but while entering the value here, we have to enter it as S5. From the state 0 on reading ID, it enters into the state 5. Let us enter it as S5. From I1, further there are no transitions, but by default, 1, dollar is to be declared as except state. I already told the reason in the previous example. Because when the parser has completed reading this S, now it is ready to get reduced to S dash. S dash is a new start symbol. From this we can come to know that the entire grammar is parsed. Alright. Okay, now from I2, let us continue from I2. From I2 on equal to, it enters into the state I6. So let me enter the value as S6. Then from I3, there are no transition. Let us move to the state I4. From I4, on reading R, it enters into the state 7. I4 means it is a fourth state. From reading R, it enters into the state 7. From I4 on reading L, it enters into the state I8. From I4 on reading star, star is a terminal, we have to enter into the action column. From 4 on reading star, it enters into the 4 itself. So here I have to enter the value as S4. Similarly, from the state 4 on reading ID, it enters into the state 5, let it be S5. Yes, now from I5, I mean the fifth state, there are no transitions. So let us move on to the sixth state. From the sixth state on reading L, it enters into the state 8. So from the sixth state on reading L, it enters into the state 8. From the sixth state on reading star, the value to be entered is S4. On reading ID, the value is S5 because the state is I5. From the sixth state on reading R, it enters into the state I9. So let me enter the value as 9 here. So we have in fact written the go to column as well as the action column with the shift rules. Now we are supposed to enter the reduce rules into the table. So how do we do that? In order to enter the reduce rules into the table, we have to use this follow tables. Okay, now once again let us scan the LR0 automaton. Just find out the states which contains the rules where the dot is placed at the rightmost end. So consider the state I1 which has a dot at the rightmost end. Yes, accordingly we have entered 1 comma dollar is equal to accepting state. In fact, this is the augmented rule. We have included the rule, so nothing to consider much. Now come to the state I2. The state I2 contains a rule R derives L dot. Please don't ignore this. This is I have scratched already. R derives L dot. Right? So before entering the rule into the table, let us number the rules also. This is rule number 1, rule number 2, rule number 3, 4 and 5. So R derives L is nothing but the rule number 5. So where I have to enter this value? Consider the follow set of R. What is a follow set of R? It is nothing but dollar as well as equal to. Right? So in the state 2, because this rule is available in the state 2, and the follow set of R in the sense, so I have to consider entries in the cell state 2. Consider the follow set of R. One is dollar, another one is equal to. Against these cell entries, I have to enter this rule number. What is the rule number? It is nothing but 5. So how do I enter this? Here I have to enter it as R5 2 comma equal to, and 2 comma dollar is also R5. Right? Okay, now let us move on to the state I3. In the state I3, there is a rule number 2 whose dot is kept at the rightmost end, isn't it? So where do I fill this reduce rule? State number is 3. Consider the follow set of S, which is nothing but dollar. So 3 comma dollar is equal to R2. I have to enter. So 3 comma dollar is equal to R2. R2 is nothing but reduce by rule number 2. Now come to the state I4. In the state I4, we don't have any rule which has dot at the rightmost end. Come to the state I5, we have the rule L derives ID. The rule number is in fact 4. The rule number 4 whose dot is at the rightmost end. So where I will enter this rule in my table? First you consider the state number 5. Consider the follow set of L. What is the follow set of L? Equal to as well as dollar. So 5 comma dollar 5 comma equal to, both the cells we are going to enter the value R4. 4 is a rule number. R stands for reduce action. So let me enter the value. 5 comma dollar as well as 5 comma equal to, both are R4. Now move on to the state I6. I6 has no rule which has dot at the right end. I7, yes, consider this rule. This rule is having the dot at the rightmost end. What is the rule number? The rule number is 3. So where I have to enter the rule number 3? 7 comma follow set of L. 7 comma dollar 7 comma equal to is equal to R3. 7 comma equal to as well as 7 comma dollar, I have to enter the value R3. Come to the state 8. This is a rule number 5. So where I will be entering, very simple, 8 comma, follow set of R you have to consider. 8 comma dollar, 8 comma equal to is nothing but R5. Here as well as here I have to enter the value R5. R5 means reduce by rule number 5. Now come to the state I9. I9 contains the rule number 1. So where do I enter this? Consider the follow set of yes. 9 comma dollar is rule 1. 9 comma dollar is rule 1. Yes. Now we finished filling the SLR parsing table. Now the question is whether the grammar can parse the given string. No, it cannot parse a given string because the action column of the cell 2 comma equal to has two entries. One is shift conflict as well as the reduce conflict. Shift reduce conflict is existing in this position. So this grammar is suitable, not suitable for LR parser construction. And if you try to parse any string which is derived from the grammar, cannot be parsed also. In fact, we have not constructed LR parser for the given grammar, or this grammar is not suitable for LR parser construction. I hope you have understood this. Please subscribe to my channel and share my videos with your friends. Thank you, students.